So a couple things in this question. This is the next level of question. It says calculate the sum of a geometric series. We only have one formula for the sum of a geometric series. So I'll write it out. It's Sn T1. Same formula we've been using all the way up till now. Okay? And we want to find the sum. So this is what we want to find. However, we run into a problem this time. And the problem is this. We know term 1. That's not a problem. Can you tell me what we're multiplying by? -5. Just 5. So we know what r is. How many terms are there? We have a problem. There are two things that we don't know. This is what we're asked to find. We're asked to calculate the sum, but we also don't know n. If we knew everything except for one thing in this equation, you can use algebra to solve for it. But we don't know what n is. So we can't use this equation yet. And before we can use this equation to find Sn, we need to find n first. The only other formula that we have for geometric sequences is that Tn equals T1 r to the n minus 1. And this is what we want to find. Do we know r? Yes. Do we know term 1? And in this case, what are we going to think of Tn as? If we want to know how many there are, we're going to think of it as the last term. So I know everything in this formula. I can plug in 46,875 with a negative. That's my last term. -3, that's my first term. I'm multiplying by 5. That's r to the n minus 1. $46,875 divided by 3 . So I divided both sides by -3. And we get to this point. Now we had a question like this the other day. Currently, you have no algebraic method to solve for n as an exponent yet. So what you do is you go to your calculator and say 15, let's just try, 15,625. Try a number. What do you think it might be?
5 to the 6.
It's 5 to the 6. Perfect!
Yo!
Nice first guess. 5 to the 6. If you guessed wrong, okay? How badly do we want to guess wrong? Like 12?
18.
Oh, that's way too big. So that would tell you that 12 was too much. And then you would work your way down. It wouldn't take you very long to find out that it's 5 to the 6. Once you know that 15,625 is 5 to the power 6, can someone tell me what n has to be? Close. 7. N has to be 7 if 5 to the 6 equals 5 to the n minus 1. And now, we found n. Now that we can go back to that first formula, and now we can find the sum. We want to find the sum of the first 7 terms. We know term 1 is -3. We know that r was 5. And now we know that n is 7. Plug that into your calculator, push enter, and you get -58,593. Question number 9 for practice.